Hi, my name is Thảo Ly. I'm doing this video for my project talking about landfall analysis and pattern of hurricane impact in the United States from 1851 to 2015. The structure of the presentation includes introduction, background, data analysis, result, and discussion and conclusion. Introduction. Hurricanes are one of the major natural disturbances affect human livelihoods and property in coastal zones worldwide. This study examines the landfall area impacted by tropical cyclone activity in the North Atlantic Basin using GIS point pattern analysis, bowling overlay meters, and kernel density estimation to generate spatial hurricane risk map in United States. High quality GIS database supports the spatial analysis tool to approach to the hurricane hazard assessment. If we use GIS application to predict and assess the hurricane impact, then we can develop a natural hazard plan for future storms. Number 2, talking about background. Since 1851, a lot of hurricanes and storms occur in 19 states along the Atlantic Ocean and Gulf Coast. Some offshore are not affected, while other multi-states were affected by force wind on land. The study area are the north-central Gulf of Mexico coast and the Atlantic Basin because these locations are shortest return periods for tropical cyclones. Graphic information systems have become the common application for analyzing and displaying tropical cyclone data. Number 3, talking about data and meters. Tropical cyclone data. The first data sets are watching and warning breaking point from 1851 to 2015 represent for landfall area. The data is conveyed from the National Weather Service for life-threatening. The second database shapefile tropical cyclone track from 1851 to 2004 is collected from the National Oceanic and Atmosphere Administration Hurricane Research. It contains all Atlantic Basin major hurricanes, the storm category, wind speed, and much more. Major hurricanes are classified by the Saffir-Simpson hurricane scale, a category from 1 to 5 at the time of the landfall. This is the Saffir-Simpson hurricane wind scale table. Show the category from 1 to 5. The major hurricane start from 3, 4, 5. Show the wind speed and the damage based on the wind scale. B. Meters. There are two main objectives. The first thing, I need to find the landfall area affected by hurricane using bowling overlay techniques. Bowling overlay is helpful technique to combine information on both attributes and geometry from different map layers. This overlay is a mathematics method to intersect the suitable area to meet all requirements for factor affected area. We can overlay multi-layer with the same coordinate system, the path of hurricane, land yield, breaking point with another wind speed layer to create a final map. Look at the two maps. The left map, I show all original data. I have two layers. One breaking point layer show all points, and another layer The shapefile of the United States include all county boundaries. So after using bowling overlay meters, so I have the new map show only the breaking point crossing the United States borderline, and I clean the state, mark the county boundary so to create a new map look cleaner. So bowling meter can help to intersect breaking point and merging county boundary. Overlay techniques is not only for geographic and also for attribute features. About attribute query, bowling selection help me to select the wind speed from 96 knots, 111 mph and up to create a new attribute list for category 3, 4, and 5 only. So this is the original data show the wind speed from 10 knots and up. So after I use the attribute selection, I show the wind speed from 96 up, so they will show me the new attribute table for 98 up here. So I have 3 wind speed category right now, like 3, 4, and 5. This is my first map. Using bowling overlay meters to show the hurricane watching, warning county area in U.S. coastal line from 1851 to 2004. So the red dots represent for breaking point. The green area show the landfall county per square meter. So bowling overlay meters help me to mark county boundary and intersect tropical storm breaking point to find the landfall area along the U.S. Atlantic coastal line and Gulf Coast for hurricane watching warning. This is the second meters using kernel density estimation based on wind speed of hurricane. Kernel density estimation is the density at the central location where the estimates is to be made. It takes no quantity of some phenomena and spread them across the landscape based on the spatial relationship of the location. Kernel meters can estimate the density of wind speed at any location by counting the number of events in an area. Output surface they give an indication of the region of high and low point density, provide a very good way for visualize a point pattern to detect hotspot. This is the formula to calculate density from the textbook. It show the grid of location where density to be distribution, and the formula to count the density overall. This is the second map, show the density of category 3 based on the wind speed. So the wind speed based on the Saffir-Simpson scale. So ArcMap provides the kernel density toolset to calculate the density of hurricane based on wind speed as concentrate point. Jet applied to help eliminate syntax to track the motion of hurricane over the Atlantic Ocean. This is another map using kernel density meters to show the category 5 and 4 wind speed density. So kernel density estimation shows the density of major hurricane category 3, 4, and 5. The frequency spread out based on the tropical Ceylon pond pattern. Number 4, I will talk about the result and discussion. Two maps show 105 counties hit by hurricane and storm in the red dot along the coast. Major hurricane category 4 and higher count from 96 knots or 111 mph and higher. The more intensive storm can be expected to yield more damage. Coast density estimates provide the most frequency area tropical Ceylon occurring in two zones, Gulf Coast and East Atlantic Ocean. The highest density of categories 4 and 5 concentrate in Gulf of Mexico. Some category 4 show in propensity to venture northward towards to North Carolina. Besides the result, the important issue is storm intensity. Accurately definition intensity is quite challenging. Developing an accurate object measure of storm intensity in the future area of research. To create a rich zone map, the study may lead to more application of spatial analysis to review undercover tropical Ceylon strain. This is conclusion. In this report, breaking point value represent the total number of watching in one zone in the county. But we want to learn overlay the kernel density estimation. We can calculate and create a surface showing predicted distribution of the hotspots throughout the landscape. High-quality GIS database supports the spatial analysis tool to approach the hurricane hazard assessment that will affect vulnerable community. Analyst interaction always play the critical role in the process of hotspot and analysis. So this is the reference. I get the data from one shapefile for nature disaster and another for breaking point. So thank you very much for watching my video. Thanks. Bye bye.